super fun stuff. You just got your last chapter packet. If you look at the front of it, it goes all the way to the final. It's your last set of warm-ups, your last set of resource pages. The only other packet type thing I'm going to give you is the review for the final exam, which is not in this packet. And then the final itself is also several pages stapled together, but that I don't know if you want to call it a packet or not. This could be your last, I don't know, however you want to look at it. Yes. Scantron, just like first semester. I will talk a lot more about that. I have the topics for you and everything. But if you look, we still have a quiz and a test before that. So we need to cool our jets on that. Okay. So evaluate each arithmetic series described. Sum equals n over 2 first term plus last term. I'm really tired of doing these. I don't know if you are also, but it's fine. It's good. It's fine. Evaluate means find the sum. So in these problems, the sum is the variable. N is 7. First term is -4. And then I need to find the last term. Over here, I'm going to write the equation. And for my visual people here, I'm going to say, okay, it starts at -4 and it goes up 4 each time. Gosh, I really could just write this out to the 7th term, but I'm not going to do that because I don't want to I don't want to, it won't work every time. Well, it will work every time, but it's just like, sometimes it's not 7, sometimes it's like 47. But anyway, okay. What is the equation of this series? If I make the arrows, maybe it will help. What's the equation of this series? Yes, thank you. 4n minus 8. 4n minus 8. And to find the 7th term, I'm going to plug in 7. Which looks like it's 20. Okay, so sum equals 7 over 2 times 16. 16 divided by 2 is 8 times 7 is 56. All right. Now I see number 3 is setting me up for quad formula. I didn't leave you a whole lot of room, so I'm going to write super tiny. So I have sum equals n over 2 first term. Okay, so first term is going to be 4 times 1 minus 3, which is 1. Everybody good with that? Okay, and now I'm going to get the last term, which is what I'm going to get when I plug in n, which is 4n minus 3. Okay, times 2 on both sides. Cripes. What is 2? I don't know where I'm not prepared for class. Something with a 2, 40, 50, 500, 552. Look, I almost did it. I sort of almost did it. I know you're smarter than me. 276 times 2, 552 equals n. Okay, and then I'm gonna combine the 1 and the -3, so I have 4n minus 2. Distribute. Now move the 552 over. N equals negative b. B is already negative, so it's going to be positive. Plus or minus, really only need the plus. B squared minus 4ac all over 2a. It looks like from your test on Friday that some people still don't know that a negative times a negative is a positive. I'll just keep working on that. Negative 2 squared minus 4 times 4 times negative 552. 8,836. Square root of 8,836 is 94. And again, we only need the plus one. 2 plus 94 divided by 8 is 12. All right, that is it for that. So you guys are done with the packet. There's no resource pages or anything for today. Today we're going to start rational expressions. Guinan does a ton of these in pre-calc, a ton, like a lot, like they're all the way through the year. So we need to make sure that you're ready for Guinan. So that is, that's going to be important. The second half of the chapter is substitution elimination method again. You guys remember elimination method? You have like two equations and sometimes you multiply by something to cancel stuff out, except for that it's going to have x, y, and z in it, not just x and y. And then we're also going to do 3D graphing with x, y, and z axis, which is like my favorite. It's super fun. It's super simple and super fun. It's just that you have to pretend like an arrow is coming toward you. Super duper fun. And so that's that. Let's see what my situation is here. So today we're going to talk about giant ones. I think maybe you talked about giant ones the last time in like 7th grade. Yeah, today's giant one day. I'm actually going to draw the giant obnoxious ones today a couple of times before I give up. Yeah, I know. Today's lesson is extremely simple, very, very simple. You do need to know how to factor though. The number one skill predictor of success for the first half of this chapter is factoring. Homework is 11:7 to 11:13, and the joke says it's not even summer and I already have a tan. Come on, people, that's funny. I can't do any better than that. Okay. Your expectations are too high if you think that I can do better than that. What? Okay, I'm not showing you any jokes for the rest of the year after no one's comment.
Extreme.
No, I just didn't wake up until Monday morning. It didn't come off as funny. I think if you would have showed it on like a Friday morning, it would have come off as a lot more funny.
My fault again. Good, good.
I like
All right, so we're gonna start our very, very simple section here, which is good for a Monday morning. There is nothing challenging today, unless you don't know how to factor. And if you made it this far, on the grace of not knowing how to factor, well, good for you. Also, I had a near incident this morning. I got flare pen on Pascal. I know, I had to go scrub him off. He's fine now.
Is he traumatized?
He's got the same expression as usual.
That's his traumatized.
Yeah. He was slightly disappointed in the amount of people who didn't take the leading coefficients to the exponents in his problem on the test, but you know. Other than that, he's fine. It was just little stuff. Okay, so for a lot of these problems, we're going to do a gut check type situation. Do you feel like 16x over 16x is what? Okay, you feel like that? And what we're going to do is we're going to test our theory by plugging stuff in. Now, my normal go-to is 0. I like to plug 0 into stuff because I'm lazy. I put a note over here specifically that I can't do 0 though. So we're going to talk about that in a second. But I'm going to do something like 2 or 1. Let's do 1 because that's the second laziest. Okay, so if x equals 1, then 16 times 1 over 16 times 1, I just plugged it in. I just plugged a 1 into this. That's all I did. Just put a 1 in there. 16 times 1 over 16 times 1 is 16 over 16, which is 1. We want to make sure that it works every time and not just select times. Okay, now what we're going to do is you're going to do this with me. You're going to go throw back to your middle school days there, and you're going to throw a giant 1 over top of that. And this is what we call a giant 1. If you did not go to Benicia Middle School, a giant 1 is some kind of algebraic expression over the same exact algebraic expression. So something over itself. Why is it giant? Because 16x is a much bigger thing to write than 1. Okay, now, why can't x equal 0? Well, true, but in this particular problem, what do you know about 0 in a denominator? Yeah, okay. So We're going to write it in a much more sophisticated fashion over here. Okay. So, excluded values is the vocab term that you need to remember for all of the problems that we do in chapter 11. So let's just say that you're taking the next quiz. You would have a problem, something like this. Not necessarily like this, but it might not be exactly the same on the top or bottom. And I would say the directions would be simplify and state all excluded values. Okay, and so what you're gonna have to do is simplify. Now we can tell this one is gonna be easy to simplify. Later on, when we get to number 3, we're gonna actually have to do a little bit of work, but this one we don't really have to do any work, but you're gonna have some, or you're gonna have to do some work, factoring most likely. Factoring is the name of the game here. And then you're gonna have to state the values that won't work in each one. In that first one that we just did a second ago, 16x over 16x, 0 was the thing that wouldn't work. Okay, now let's talk about C here. So first thing I want to ask you is this true? Does your gut tell you that x minus 3 over x minus 3 is what? Okay, so we're going to make sure, because, you know, we're very untrusting over here. So we're going to plug 1 in, just like we did up here. So I put 1 in there. I put 1 in there. -2 over -2 equals 1. Okay, and I want you guys to, we're not going to do this every time, I promise you. Does anyone have anything that looks really interesting that does not look like a 1 at all? Like maybe say a mailbox or something? Yeah, giant mailbox, I don't know. Okay, so this is 1, which is great, good news. However, my next question is, what is the excluded value in this problem? And when I say that, what will make the denominator 0? 3. Okay, so you're going to say x cannot equal 3 in this problem. I want you to think of it like, you know how, I'm going to write this on a separate, don't mind this. This is my list of things I have to copy. I want you to think of it like this. You know what this is, right? This is a factor. Okay, so that means just like factor to root, you switch the sign when you take it out. See what I mean? Okay. All right, now write this stuff, please. D and E. Then you're going to see, once we get to number 3, problems that actually like we have to do some stuff. That's a Z. This is a Z and a Z right there. Excellent question. Thank you for asking. If this seems like extremely simple, that's because it is. And that's a good thing. Okay, let's start with this. Gut feeling on this one, does this equal 1? Yes. Okay, so I'm gonna put the giant 1 on. I'm gonna put a check mark for yes. However, what is the excluded value here? X cannot equal -7. So yes, this is 1. However, X can't be -7. Okay, next one. This little guy here. Is 7x over 7x 1? Yes. Oh, I'm going to be so ready to be done with these at the end of the day. Yes. But what can x not equal in this problem? 0. Why? Because 7 times 0 is 0. All right, last one for D. 7 over x divided by 7 over x. Is that 1? It is. You might want to, if you're not super sure about it, come over here somewhere in the white space and go keep, change, flip. Okay. Keep, change, flip shows that that is 1. And what can x not equal in this problem? 0. It would cause a problem in the top fraction, and it would cause a problem in the bottom fraction both. Okay. E. Z over Z. What's Z over Z? What? Oh, I didn't draw the giant 1 over the... Oh, goodness. This is going to be bad. Oh, hey. It could be worse. Okay. Now, this is 1. So 1 times anything is itself, right? Okay, so this is a true statement. However, what are the excluded values? 0 for what letters though? Z cannot, yes, good, excellent, Nolan. Z cannot equal 0 and Y cannot equal 0. Okay, very important here. We're going to write a note, get excluded values from the problem, not the answer. Okay, why does that matter? Because sometimes we're going to cancel stuff out just like we did here, but Z is still a fraction, and so it still has an excluded value of 0. Okay, I'm going to give you like a few minutes to set up number 3. None of these problems are long. They are just, it's more like time to actually write them down than it is to do them. And right about in the middle of this problem is where the giant ones are just going to end for me. I can't, I'm not going to, there's not, I'm not, it's not, can't do it. I really hung in there though. Also, I'm going to start using a red pen to cancel things, very similar to Mr. Guinan's die, die, die. Do any of you remember that? Oh, so when he would teach this, he'd have like stuff that cancels, and he would take a red pen and like, like cancel it out to make people laugh. It's supposed to be funny. You don't remember? Does he not do it anymore? Maybe it's only in pre-calc because of this lesson, these lessons right here. Okay, anyway, all right. Hey, what is x squared over x squared? 1. Great job. Okay, however, what can x not be? What will make 0 on the bottom? 0. Okay, that problem is done. Okay. What is x over x times x over x times x over 3? Okay, so what I like to do, if you're an artiste, you might want to do that. And hopefully you can see that this is a 1. And this is a 1. So 1 times x over 3 is x over 3. Okay, however, if x is not, okay, so remember I said get excluded values from the problem, not the answer. So 0. This is not one of those times where it's like, you know, on the flow charts for math 1, you wrote given and everything because you didn't know. Like, it's not always 0. It's 0 sometimes. Okay, now C. Do you recognize this front thing as 1? Okay, that's good. That's excellent. Okay, so that's 1 times anything is itself. And in this problem, really, I don't care so much about the problem as I do the excluded values. Okay, what are the excluded values in this problem? Correct. X cannot equal 2. X cannot equal 1. 2 from this denominator, 1 from this denominator. Okay, now this is really important. Right here, we're going to get to the part where is it okay to reduce things diagonally? That's my question. Is it okay to reduce things diagonally? Is this 1 and this 1? Yes. Okay, but really hard to draw giant 1s around that. So what we do is we go, okay, that makes a 1. That makes a 1. What do you think the fear is with me just crossing it out? What are students going to do if they don't really understand the whole rest of the beginning of this lesson? What's the answer they're going to put? They're going to put 0 because they think that I canceled everything. That means there's nothing left. That's not true. It's the x's made a 1 and the 9's made a 1. So the answer is 1. Another way to do this would just be put 9x over 9x equals 1. However, there's also an excluded value of 0. Okay, do you see why we don't jump immediately to just canceling stuff? And I'm going to cancel stuff. The whole rest of the chapter, there's going to be canceling. What I need you to know is those canceling means 1s, not 0s. Okay, this guy. Do you see any 1s? Yeah, h over h. You can cross out these 2 h's or these 2 h's. It doesn't matter. Final answer is hk. If what? Which is the problem here, h or k? H, because it's in the bottom, and H cannot be 0. Okay, F. Does anybody recognize a 1 in F? Yes. M plus 6 over M plus 6 is 1. That means that I have 2M minus 5 over 3M plus 1. Okay, this is where it starts to get fun. If. Okay, so look here. What can M not be in this first part? First part, -6. Okay, and then this one. Can you guys solve this for M in your head? Anybody other than Nolan able to solve this for M in their head? -1/3, -1/3. Okay, if you don't see that, that's okay. Just go 3M plus 1 equals 0 somewhere on your paper. -1 divided by 3. But I think we did a lot of that with parabolas. I think you guys can do that in your head, most of you. Okay, last one. Last two before we move on to the very, very horrible thing that students do sometimes that they really should not. Okay. All right, G. So what I'm going to do for G, if it were me, I would not do this way, but because we're just starting out and you guys are just getting used to this chapter, I'm going to write this out. I would not normally write this out, but I'm going to write it out today because we're just getting started. Does anyone see a 1 now? You see those two make a 1? Okay. And what is 6 divided by 3? Nobody knows 6 divided by 3. That's great. Okay, and then n minus 2 is left over. What? Oh, fine. Okay. Now, I have a lot of advanced people in here. If I was doing this problem, I wouldn't do this. What I would do would be I would cancel out the bottom n minus 2, and I would change this exponent to a 1. So I would say one of these cancels out with one of those. I would just go bam, cross out exponent, change it to a 1. But, you know, that's me. I'm old and do the maths all the time. Okay, what can n not equal in this problem? 2. Beautiful. Okay, last one. Does anyone see a 1? Anybody see a 1? Yeah, 3 minus 2k. Does anybody know why I picked this problem? Can you see it? Can you see the teacher's motivation here? What am I afraid is going to happen? Yeah, I'm going to put a 0 there, and then you're going to think it's 0, but that's not true. You have to remember that this is a 1. Okay, so now if you guys could take 10 seconds in your groups and tell me what the 2 excluded values are for this. This is like advanced excluded values class. See if you can do it in your head. I don't say that very often, but Okay, the first one is positive 1/4. So what I do in my mind is I just add 1 to both sides, divide by 4. This one's a little bit harder. The answer for this one is positive 3/2. Anybody want me to show it? Can you? Can I? Yes. Okay. 3 minus 2k equals 0. Minus 3. If you can't do that in your head, no worries. Totally fine. Just throw this little ditty somewhere in your paper. Okay. All right, now we're going to get to common mistakes. Woo. And then in number 5, we're going to practice factoring. No. What? Okay, so some of these are true, some of them are false. There's 2 true ones, 2 false ones here. And the goal is for us to figure out what's legal to cross out and what's not. So that's what we're trying to do here. My question in A is it okay to cross out those X's? Okay, in order to do that, we're going to plug in 1. Why did I not plug in 0? Yep, beautiful. 0 is an excluded value in this problem. So let X equals 1. I have 4 times 1 over 1, which is 4. Okay, so this is okay to cross out. Okay, the question here is, does this X over X also make 1? So I would have 4 plus 1 is 5. Going to test our theory. Okay, no one's saying anything. It feels, hopefully it doesn't feel right to you. This worked. Is it always going to work though? No. Excellent. And why does it work for one? Well, just because something divided by itself by one is itself. Does anybody know what the vocab word is for one? You don't probably. You won't. It's got its own. It's got its own vocab word, and it's called the multiplicative identity. That is a college word for you, out of abstract algebra. So 0 is the additive identity, and 1 is the multiplicative identity, which means it retains its original value. Okay, so taking what you learned from B, looking at C, do you think it's okay to cross out these x's and cross out these 3's and get x squared? So let's try it. Should we try something other than 1? Let's try 2 just to be safe. Okay, so this is the question we're asking ourselves. So I plugged 2 in here, 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 and here. And what would the top be? 4 plus 5 is 9 over 5 equals 4. As far as you know in your math career, does 9/5 equal 4? No. Okay, now that I've got you all skeptical, do you think that I can cross out these x plus 3's? Yeah. Okay, do you see the difference? Addition versus multiplication, basically, is what we're looking for. Okay, thank you. Okay, so I'm really hoping that you see the difference between these two. These are excellent examples to have right next to each other. Addition or subtraction, we do not cross them out. Multiplication is a yes. Okay, last problem of the day. It's going to be some good old straight up factoring. I don't know if I told you guys, but I did not learn the diamond in a box in high school. Did I tell you this already? I just had to guess and check. There is so much factoring at the beginning of chapter 11 that I will not be doing the diamond and box for every problem. I'm going to do them all today because you need a reminder. We haven't done them in a hot minute, except for that one like log problem. But I'm not going to do them all the time. You guys have the diamond and box in your toolkit for life, but you can use that every single time. I'm not going to do it because I'm too lazy. But every time that I don't do it, you guys can just note to yourself that Mrs. Talbot did diamond and box in her head. It's like a time-saving device for while we're together. But please know, diamond and box is not going anywhere. It will always be there for you. It's your reliable Camry in your garage. Will start up for you every time. Okay. Two of these problems are going to take a minute. The other two are going to be extremely quick. So these two will take a minute. These two are super fast. Okay, we're going to do two things in each of these. We're going to simplify and find the excluded values. So here we go. Can I cross out 9? No. Can I cross out x squared? No. Okay, right here, did I just say, don't cross out the stuff until it's multiplication? Okay, so what do you do instead? You factor. I'm going to factor the top over here. Okay. The top of this would factor to x plus 3, x plus 3. Are you guys all okay with that? Diamond and box. This is an easy one. Okay, now the bottom though, I would not diamond and box this. Does anybody know what this is? Difference of two squares. Thank you for saying that. So notice these are both perfect squares and it's a difference. So I go like this, x, 3, 3. Remember this guy? X plus 3, x minus 3. Math 2 stuff is never going away, just so you know. Okay, now you can look for ones. Do you see ones? Do you see 1, 1? I see 1, 1. It's right here. I think I'm doing a fine job. Thank you, Mom. Doing a fine job. Okay. Okay, now I simplified. My simplifying answer is done, but I did not find the excluded values. If what can x not equal? So remember, find it from the problem. Easiest to do it from the factored form. What can x not be here? -3 and +3. Okay. B. What multiplies to be -20 nets to be -1, -5, and 4? Don't forget about the multiplying by one thing. Okay, almost done with that. Do you spot a one? And when you're doing these problems, to give you like a super insider math teacher secret, they should have factors in common so that you can find a one and cross things out. Like we wouldn't set this problem up if there wasn't stuff to cancel normally. Like if you don't get one, I mean, you might have done something wrong, I'm saying. Anyway, do you guys see the x plus 2 giant one? Do you see it? Okay, so final answer is 2x minus 5 over 3x plus 1 if x does not equal. Now remember, you're only looking at the denominators. X can't be what in this one? -2. And x cannot equal -1/3. Beautiful. Okay. To see, I'm not going to ask you to find the excluded values. I'm just going to want you to notice that that is what. I want to warn you that problems like this come up where you could factor the top and you could factor the bottom. You could spend all day on that. But if you just notice the top and the bottom are the same, one, you're out. I'm not going to ask you to find the excluded values because I actually graphed it and I noticed that they're horrible and I don't want to do it. Okay, last bit. This problem is to remind you that something exists called GCF. GCF is a thing that exists. What's the GCF of the top? X. What's the GCF of the bottom? 2. You spot a 1. Yes, great. Okay, and then excluded values. Do we care about the 2? No, that's fine. It's just a constant. What we care about is what x can't be, and x cannot be -4. And I'm done. 1 minute to spare.